Alright guys, welcome back. We're going to be solving another question from the second chapter of the Meriam textbook, question 110, and we know the tension in the supporting cable AB is 10 kilonewtons. We need to write the force which the cable exerts on the boom BC as a vector T, and we also need to determine the angles theta x, theta y, and theta z, which the line of action of T forms with the positive xyz axis. If we want to find a force in a vector format, so we have our tension, which is what we are looking for, times the magnitude, which is 10, times the unit vector, which we're going to show it with n or lambda for the tension in the cable that we are looking for. So the force that is applying on member BC would be in this direction. So the tension is starting from B toward A. So if we want to show it, there are two ways. We can either show it as NBA, or the other way is to show it like A and A relative to B both work. And as I said, there's another way to show it, lambda BA or lambda A relative to B. And obviously our unit vector is the vector in here, and at the end from this formula we're going to get tension in vector format. So how are we going to find the NBA? For finding this, we need to find the vector from B to A, and we can divide that by the magnitude of BA, and pretty easy we can find the unit vector in this, and we just have to figure out how we are moving on XYZ axis when we are moving from point B to A. So if you look at this on the x-axis, we are going from this part, which is the origin, to here. So what we need is this part, which we know is 4 meters from here. And since we are moving toward the positive direction of x, we'll have positive. So for A, that's what we have for x component. Let's move on to y-axis. So if you look at our y-axis from B to A, since our point A is in the xy plane, so we have this plane and A is on this plane, the way we're gonna move for y is from point B to C, which is the origin. So obviously we are going in the opposite direction of y, so we have a negative sign. And if we want to figure out the distance from point B to C, we have 5 plus 2.5, which is 7.5 J. And I'm going to show the Z component in green. And for the Z component, again, our B is in a y-axis, and going from B, it means that we are moving in this direction on z-axis. So all we need to figure out is this distance, which is pretty easy, 5 meters, going in the positive direction of z, so we have a positive. So that's pretty much everything for the numerator. The other way is just to find the coordinates of point A and subtract that by the coordinates of B. We're gonna get the same thing, so no changes. It's up to you guys if you're more comfortable with going the coordinates or just see how you're moving on XYZ directions. Probably finding the coordinates is a little bit safer, but it might take a bit longer time. And now we're going to move on to the denominator, which is the magnitude of the BA. And this is pretty easy. We have the same formula for 2D and 3D. If we have three components, let's say we have this force of F, which has A, B, and C component. If you want to find the magnitude of F, you just have the square root of each of these to the power of 2. So A squared plus B squared plus C squared. And same for the 2D. 2D means we don't have this component. So basically we have the same thing, we just don't have the C2 part. So we have the square root of each of the component to the power of 2. So that works for everything. So don't get scared by how we're going to find the magnitude, and don't get confused this one with what we have for the magnitude of the cable, which is 10 kilonewton. That's for the next step. We're still not there yet. So the square root of 4 squared plus 7.5 squared plus 5 squared. No need to be worried about the negative sign because it's going to go to the power of 2, so it will be cancelled out anyway. So that's pretty much it. We have everything that we need, and if we want to find our t, we basically have t times the unit vector. T is 10 kilonewton, and the unit vector in here is what we have in here, 4i minus 7.5j plus 5k, and we can actually calculate this, our denominator. So we basically have the square root of 4 squared plus 7.5 squared plus 5 squared. So that's going to give us 9.86. So all we need to do in here is that, so we're going to have 10 over 9.86 times 4i minus 7.5j plus 5k. So we have to multiply this in each of them. And if we do that, we're going to get our T, which will be kilonewton at the end. So our T would be 40 divided by 9.86. That's going to give us 4.06. That would be our I, minus 75. 75 divided by 9.86, 7.61 J, and the last one would be 50 divided by 9.86, which will be 5.07 K, and the unit would be kilonewton. So that's the answer for the part of the question that we needed to find the tension in the cable BC in vector format. So that's everything. And obviously we have a force that has XYZ component, and if we want to find the angle theta, so what's going to happen is that if we have like some force in 3D like that, R, and if this is our X, Y, and this is our Z, this will be our Fx, and we can call this theta X. And if we want to find the Fx, if we want to find the theta X, we basically have cosine of theta X is equal to Fx over F, which is the adjacent over the hypotenuse, and F in here is our R. So, and this is our F. So same thing goes for cosine of theta y, again Fy over F, and same for the theta, cosine of theta z would be Fz over F, meaning if we want to find the theta x, theta y, theta z, all we need to do in here is just to find the x, y, z components and divide it by the magnitude of the force. So in here, this part is basically equal to, this is our Fx, which will be F cosine of theta. Same for the other one, so which is coming from here, our Fx would be F cosine of theta, and same for the y and z. So our Fx and F is basically the x component of the t and the t that we have in here. So cosine of theta x would be 4 over 06 divided by 10. So theta x would be the cosine inverse of 4.06 divided by 10. So if we calculate that, we'll have cosine reverse of 4.06 divided by 10. That's going to give us 66.6. The theta y would be what we have in here, which is the cosine inverse of minus 7.61 divided by 10. That's going to give us minus 139.55. And the theta z would be the cosine inverse of our z component, 5.07 divided by 10, which is going to be 59.5. And that's the answer for the second part of the question, where we needed to find the angles theta y, theta x, theta y, and theta z. Hope everything was clear. So let me know if you guys have any question. If anything is not clear, feel free to drop it in the comment section. We have 3 different textbooks that we are covering in this channel. Feel free to check out the playlist. The questions are sorted based on each chapter, from chapter 1 to next ones. And you guys take care. I'll see you in the next video. Have a good one.